All right, we are live.
I'm not going to do anything with them except throw them out.
So if you want them,
All right. This was an interesting test. The first test in here was really bad. This second test was an improvement. So what I'm going to do is on the final exam, I'm going to let you have the ability to replace all 4 tests completely if you do better on all 4 parts. So instead of averaging a few of them and replacing one, you can replace all 4 of them. I'm doing this in the hopes that since you got the better grade on this one, you don't have to worry about the first test dragging you down. You can just make it up later on. And plus, the stuff on the first test should be easier now that you're doing the second test and third test. So your final is going to be a little more in your favor. For those of you that are watching in WebEx land, do I have my voice on? I can't see. Check. See if it looks like, yeah, I'm talking. Okay, good. For those of you that are online and not in class, you can ask me to scan your exams in. I can email. Just send me an email if you want that done. With all that said, are there any questions on this exam? Problems that you would like me to do? 7. Problem 7, part B. 7B. Oh, let me bring up the test for those that are at home. I'll do it this way because I was going to pull up online, but I think, let's see if you, I don't know if that's going to be good, and that's not going to be good enough. Let me come back to here. Blackboard. Do you guys know where I put these exams? Right, so you go into courses, you go in here, go into old tests, and of course choose our semester. You can feel free to practice and play with any of these other ones you want. They're good practice. My tests don't change very much from semester to semester. I gotta remember to put a regular one in there, but yep, sure do. All right, let's pop then into problem number 7, which is this horrible problem. Okay. I'm gonna have to write it up because I wrote all over this thing. So I'm gonna write it up on the board. And I think I'm gonna do both parts. Did I not warn you that this was being a terrible part? I told you beforehand, I said it was gonna be bad, and I know because I've done this since, when I was going to school, the world was black and white. I mean, literally, there's no color. Just like old movies, we didn't have color back in those days. So anyways, I'll write them up then, since I can't even cut and paste them. Okay. All right, I don't think they can actually see that thing at all. So I'll write it up. All right, so this is for test 2. All right, before I do anything else, if you were asked a question about perpendicular and parallel to this particular line, the thing that you need to know about this line is its slope. What is the slope of the line I gave you? 2. So we need this information. So before I go further, if I have a line that's parallel to that, what is the slope of that line? No. Parallel is the same slope.
Parallel, yes, that's it.
All right, now if it's perpendicular, what is it? Not quite.
Well, 1/2.
Not quite.
Well, -1/2.
Negative 1/2. It's the negative reciprocal. So, all right, let's write these down and see.
Over there.
I believe this was the issue, can I, this was there, definitely unpleasant grade. Right, so we want to find. It's parallel. Passes. Through the. Now, it's funny because I would never, if I thought about this in some detail, I never would have given you a point that had the same X and Y. Reason why is when I go to grade you, if you made a mistake, I have no idea if you didn't know which one was X or Y. You're gonna get it right either way. So it was a bad choice on my part as far as evaluating. But anyways, the line is parallel. We need this information. What's the slope of this line? That's right. So we know that our line looks like this. Right, I'm not done with it yet, though. In order to figure out what the line is, what do I need to do now? Plug in X and Y. So you won't be able to tell him because both of them are 7, but I'll replace Y with 7 and I'll replace X with 7. So you get 7 equals 14 plus B. Don't think I'm going to stretch your capabilities if I just immediately tell you that B is equal to -7. Just a second. That's got to be one of the funniest things I've ever done. You know what happened? Do you know what the answer to this one is?
It's too late.
Why? Look at the answer. Look at the original one. Not only did I make a mistake, first I made a mistake of putting a 7 and 7. The answer is the same as the original equation. That's wild. Yeah, it is. Well, what's funny is when I did the answers, I think I made a mistake on this part. So I have to take a look because my line came up like 2x minus 9 or something. I must make a note because I do not want to have something like that up. No, 2x minus 6. Oh, sorry. 2x minus 9, thank you. There we go. I wrote the problem down. Because I would have noticed that. I'm pretty sure I would have noticed that thing when I did the answer. So the original line was 2x minus 9. There we go. So not quite, but it was an easy problem though because the slope is the same. For the perpendicular, which is part B, find perpendicular. Point 7. Right, so for this one, now it's the perpendicular line. So for perpendicular, can you tell me what the M is going to be now? -1/2. So the equation of our line looks like this. Y equals -1/2 x plus b. Now all I gotta do is figure out the b. And how do you get that b? Plug in the x and the y. 7 equals -1/2. You might find it easier when you put doing this to put it as a 7/1. I know a lot of students find that easier. So when I multiply, we have 7 equals -7/2 plus b. There's a bunch of ways to solve this problem. It's such a simple fraction, I doubt that I want to multiply everything by 2. But I mean, if you want to, that's fine. I probably would just add 7/2 to both sides. Because it's only one step. And you're forced to do 7 plus 7/2 off to the side. So 7 is the same as 14/2. It's 21/2. So let me write my answer then. My answer is y equals -1/2 x plus 21/2. Other questions? That includes you WebEx folks too, if you got questions. I don't know if they can see the test or not. And they don't know what they done on their own test either, so. Yeah, if you WebEx people, if you go into Blackboard, you can grab a copy of this and refer to it while I do the test. All right, so let's kind of go through. Other questions on this exam, other problems that you had trouble with?
I was saying I did it, bro, 'cause I was doing it right. Second guess myself.
A line and has slope, okay. So we have. line passes through nine zero. Just a little, before I finish, a little vocabulary. What does that point represent? The X what? The X intercept. That's the X intercept. So line passes through it, so it's not the Y intercept. So that 9 in particular is not your B. If it were 0, 9, that's a different story. So line passes through the point 9, 0 and has a slope of -3/4. We want to write an equation for the line in slope intercept form. So for this one, we have, well, we know the slope already here, right here is our M. So we know that Y equals -3/4 X plus B. So we're almost there. All we need to do now is, how do we figure out what B is? Plug in the point, the XY point. So here's we plug in 9, 0. That means when Y is 0, X should be 9. And just as before, you might find it easier to put it as a 9/1. Let me multiply those. We have 0 equals 27/4, make that negative. And this has got to be the easiest equation ever to solve. All I do is add 27/4 to the other side. And I get B equals 27/4. Where is our others? So Y equals -3/4 X. It's 27. Other questions?
Same. So,
That's what I wonder in my life how many letter grade stupid mistakes have caused people. Since I've been teaching, it's got to be in the millions by now.
Further, can we do number 9? C.
Which one did you say, 9D?
9C.
Okay. That was where we're gonna graph one. I'm gonna change my paper to graphing paper for this. I never thought I probably could do 2 things, one graph, one regular, but I don't think it bothers anybody. Where's my view? Do you care if your notes come in this form or the other form? Does it matter to you? This is life as somebody with severe OCD. I struggle over these decisions. All right, what was I gonna do? Oh, yeah. All right, so this problem here was 9C. We wanted to graph the following line. We have -2X, 6Y. Now, you could have graphed this. This one would have worked out just fine if you would have grabbed it just by plotting with numbers and tried to do the intercepts, remember that table we made? You would have been able to do that this way. I'm not going to do it this way. The one way that always works for us is try to get y by itself. So the first thing I'm going to do is add 2x to both sides. So negative 6y equals 2x plus 12. I want to be very careful in the next step because as I looked at the way people were doing things, it's a little sloppy. These negative 6's cancel. And then you know this fraction that I have up here, I have to do this. Break up the fractions, something you've done all the time. You're used to putting them together. Let me fix up to my final form. 2 over 6 is 1/3, so I'm going to put negative 1/3 x minus 2. Let me pause there to make sure everybody's with me.
Something like I slow.
Oh, I see it. Okay.
So before I graph it, can you tell me first, what is the slope of this line? Negative 1/3. So does it go up or down as it travels? Downward, won't it? It'll tend downward. What about the y-intercept? What is it? Negative 2.
-2.
Get those things in. I'll see if I can sneak it over off to the side there. I'm going to minimize these folks, move them out of the way. Let's see. What in the world did I choose? All right, now give me some thick things to click on. Wait, I forgot what I was going to do. I was going to do, yeah, 2 millimeters. Okay, so I'm at the origin. Tell me where should I go from the origin to start? Yeah, tell me how did I get there? Down to negative 2. There it is. See it? Put a point there. Now that I have that point, how do I go from here? Down 1, use your directions. Down 1 to the right 3. 1, 2, 3. That's because the slope is negative. The negative means you go down. You always go right, but the negative will tell you to go up or down. Now that I'm here, I can repeat this if you want more accuracy and keep going down 1 and to the right 3, depending on how much accuracy you actually want to have. And I think I've told you before, the more of these dots that you do, the better. And there, like I said, you would have been able to find the X and Y intercepts fairly easy using the table. So now let me get a line to something thinner. I'll use that one. I won't get in there. The way it jumps on me. Like trying to reel in a fish. I got it. There you go. Is there any question about that?
Nope, I got it.
Okay.
Thank you.
Other questions? Anything?
The one about the inequality, I wanted to know, how do you know which way to shade, um, if you know what I'm talking about?
Sure, I know what you mean. All right, this guy right here, this thing
Mhm.
below. All right, so let's go ahead and graph this thing and then we'll take care of the shading part of it. Oh, wow, that line is actually really simple, isn't it? Let's do, I was gonna draw my axes here. All right, let me go ahead and get my point drawer. All right, tell me where I should start my graph. Well, I'm gonna start here at the origin. Tell me how to get there. Go up 5. 1, 2, 3, 4, 5. Good. Now, the slope is -3, which is technically -3/1, correct?
Right.
So if I'm at this point, tell me how to draw another point. Down 3, 1, 2, 3, and then what? To the right 1 unit, exactly. And then rinse and repeat as needed. I'm going to go down 3. And if you need to, like I do all the time, try to reverse yourself. So you go up 3 and to the left 1. And then let's see, how fat do I want my line? Well, everything's up there nice and tidy for me. All right, I got this. Come on. All right, I'm happy with that. Oh, okay. So I didn't fully answer the question yet. We got to shade one side of this to the left. It looks like it's almost straight up and down, but realistically, do you realize that over here, look at my cursor. Do you see over here where it's at? You want to make it bigger so do you see it over here?
Mhm.
That's below it. And up over here is above it.
Oh, I got you.
So I need to shade down here. And use whatever you want for that kind of shading. Just indicate to me somehow. My graph's got to be the worst looking ones possible. And I always feel like I've not filled in enough, but then I always break through the line and I feel like erasing and starting again. Other questions?
Thank you.
Sure. Like I say, WebEx folks, if you want your tests and you don't want to come into school, just ask me to scan them for you. The school's computer will scan it double-sided. All I got to do is pop it and it's not even hard for me to do. Okay. All right, then we will start the material for today, which is we're going to do 5.1 and 5.2 today. So I will finish that thing and pop it here. All right, how are we on graph paper? You guys got some? We're going to need it again. Tell me what I found myself some more. Tell me if you need graph paper. Definitely. Okay, what about rulers? Graph paper. I'm sorry. Great. What's this called? Solving systems by graph. So we're gonna solve some systems by graphing. What that means is here's what you're gonna be given, something like the following. I don't wanna make these up because they don't hit the right spot. Let me grab some out of the textbook. If I try to make them up off the top of my head, they're guaranteed not to cross at a point that I want. So let's pop into Alex and see what they got going. I kill some of these. You know, each of these little things up there take up processes. Did you know that? And I am limited in how many processes this computer can allow. What are we doing? Alex. I gotta remember to put a pull mark for it too. All right, let's start with number 12. So I'm just going to pull out some problems from the textbook to sort of motivate it as I do it. Okay, let me start with an observation before we actually do this. Can you tell me the slopes of these two lines? What are they? 1/2 and the slopes are different. What do you know about two lines? If their slopes are different, they are not parallel, correct? If two lines are not parallel, what do they eventually do? They eventually intersect, don't they? That's the goal of this. If we can find where they intersect, then we will simultaneously find a point X, Y that you can plug into this one and it will work, and you can plug into the second equation and it will also work. What they say, solving both systems simultaneously. So our goal is to graph these things and find out where they intersect. Now, we're only going to be able to graph a certain kind of problem. They all have to end up at good spots. Remember, it has to end up at a corner spot on your graph. Because if it ends up at like 5/11, you can forget it. This is not going to work for us. But this gives a nice visualization on the easier problems of exactly what we're looking for. So solving systems of equations is finding an intersection point. Am I still, where is, I don't want to go there. All right, so I am going to start with this first line here. Help me graph this first one. Y equals 1/2 x plus 2. Where should I start at? Starting at the origin, I'll go up 2 units. And then what? Put my point. Okay, I'm working the first line now. Right, the slope says 1/2 says you go up 1 unit and then to the right 2 units. And then you just do this as much as you need for the accuracy you desire. Yep, give him and you'll see. I'm going to draw a line through this. Don't forget. They will. They have to. In fact, if we expect to get an answer using this method, they have to cross at a good spot. So you're right. You'll see it right on one of the points. All right, let me go ahead and connect this line. Connect these points. Try to get this right. Now, you do want to be very accurate with your graphing here, because if you're off, you're not going to capture the answer. Come on, get in the right spot. I think that's right. That last point doesn't look like it was done well. But then it moved on me at the last second, didn't it? Sure did. Hey, okay. There's one. Now let's go to the next one, the 2x minus 1. Let me get my dot starter. Where do I start this graph? Y equals 2x minus 1. All right, starting here at the origin, I'm going to go down 1 unit. And the y-intercept was -1, so I'll put a click there. Got it. All right, now that I got that point, how should I proceed to generate new points? Because the slope is 2, technically 2 over 1, isn't it? So you go up 2, 1, 2, and then to the right 1. And as you said, you're going to see where they connect. Right here is our point, isn't it? These problems, if you do them right, the answer will be very evident. Hold on a second. I appreciate your excitement, though. Well, the answer is going to be a point. No, it'll be an X and a Y value. So I think I have enough here. Let me go ahead and draw a line through these as well. There. Did I choose this? I don't know if I chose the thinner one or not. We'll see what happens when I draw this thing. Ah, good. I think I got it. Yeah, okay, so there's our guy. See it right here? Let's go ahead and write up some stuff. I think I'm in the same font, so I'm going to use this red. This guy right here is the thing we are looking for. What is the location of that point? That point is 2, comma. That's the answer. The answer is a point. Yeah. That can't be true. So these are the easiest versions of problems. So I'm limited in the types of problems I can give you. You have to draw somewhere good. Exactly. You have to be able to grab. Right, you're not going to. Sometimes you said 2/3, I'm saying, no way. It's actually too common for you. Being 2/3 out of it. Now, if you take this 1 point, it'll satisfy both equations. Check this out. If I wanted to do a check of my answer, the way you check it is you plug the 2, 3 into both equations to make sure they work. So I'm going to start with the first equation. Y equals 1/2 x plus 3. And I'm going to replace y with 3 and x with 2. So I'm going to have 1/2 times 2 plus 2. What's 1/2 times 2? Oh, 2 half. No, you're right. 2 halves. That's how it in a simple way. What does 2 over 2 equal? 1. Tell me is 1. So we have 1 plus 2. Is this true then? Does that work out? Does 3 equals 1 plus 2, doesn't it? So what I have here is I've checked the first equation. Now I'll do it to the second equation. So for the second one, we have y equals 2x minus 1. I'm going to replace x with 2 and y with 3. Now you only have to go as far as tell you a very obvious until it's very obvious that you have a correct answer. Is that last equation true? 3 equals 4 minus 1, doesn't it? So that checks. That means I have checked both equations. All it means is that point was on both lines. So are we clear here what we want to do? Graph, find the intersection point, and that is the answer. Yeah.
Check the answer.
No,
Like,
Yeah.
now,
that's only for your own, but since I belong to the Professor's Guild of America, I am bound to do this kind of stuff. So I figure I have to show you, I'm not gonna do it again. So, well, I'm putting this also up on for an exam. If you take an exam and you have some time to do this, you can do that, it'd be good. Obviously, if you are taking an exam, you check an answer and it checks out, you feel very confident. Who's ever calling somebody, tell them to stop it. All right, what's next? Let me grab another one from the textbook. And I'm gonna give one to you then. So let's do well, I'll give you number 14 because it's very much like it. Same type of a problem. I am tired. Did you guys get graph like I have up on mine? So you have an intersection point of 2, -1.
this type of equation, we have to solve
Sure. Just like on the last test where you had some Y's on one side, you have to solve for Y. But let's go and take 10 minutes there. And then we'll talk about, maybe we'll do one of those and talk about the pitfalls of this kind of graphing.
To answer your question from before the break, I just got to one that I was going to do, like you were suggesting here, where they're on one like this. Let me see here. I'll find something reasonable. Hmm. Let's hold off of that. All right, I'm trying to be too cute here. Let's try to just pick something basic. Now, don't forget, you always have the method if you want to for graphing. You can always do where you try to do the intercepts. You know, you plug in 0 for X and then 0 for Y. You can always do that kind of stuff. But generally, I doubt most people really like to do that. I think it's really easy just to solve for Y and do that. I don't think that presents a lot of problem to anybody. So take a minute or two and try this. As I mentioned, you'll have to solve each of them for Y. I didn't mean to do that. I want black. Property.
All right, I put stars around the answers for the 2 lines. See if you got the exact same thing I did for those 2 equations.
Of course, once you do that, then the rest of it is exactly like the rest of the other problems that we did. So I'll start working my 2 lines. I'll work this first one. If you do like I do and graph these dots, like all the way from left to right, you'll usually run into your answer. Nope. This one here. See, I already know what the answer is going to be. As I'm graphing this line, I already ran into the point. -4, I think, is the answer. Did it intersect on this side? Okay, well, let's check some things out then. For the first line, you had +1/2 x + 2. Okay. -3/4. Okay. I didn't get that one. And as I said, as I was drawing my dots, if you do enough dots, you'll run into the answer. It's right there. See it? At -40. So you may have to solve for y. We've done this business before, so hopefully that's not too big of a deal. And there we have our answer. -40. Can you see it right here? Look at the first equation in its original. X with -4 and -4 would be positive. Y is 0, you can see it works out easily. The same problem goes with the other one. So here's my guy. -4, 0, and that's the answer. Okay, what are some problems with this graph? And we've discussed it. If the points don't go on a good spot, you have to come up with another method. Luckily for you, you have two other methods. Secondly, two lines don't have to cross. That's just that happen. Parallel lines, if they have no intersection. So what about parallel lines? What can you say about their solutions?
So it's the same.
What do you say? But I mean, what point do they intersect at? Don't. When you don't have a solution, what do you say?
No solution.
So, all right, there's actually one third possibility. Let me go ahead and move this thing up and I'll show you the three possibilities. We're doing one possibility. They cross like normal, nice, well-behaved lines. But we have two bad situations, or two situations you should at least be aware of. I'll see if I can try to make these look parallel to each other. That's right. That's if they're parallel and don't touch.
No intersection.
No intersection at all. So if you ever get a situation like this, do they look parallel? Yeah, well, if I went on forever, they might. Remember, they could intersect way, 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 way out there and beyond our graph, but let's just say they don't. How do I make sure? I'll say they're parallel lines. Parallel lines do not intersect, do they? So when you have a situation like this, you'll see no solution. There's no intersection. However, there is actually one last one where they're parallel and they do touch. How is that possible? A third possibility is this little game.
what you'll do is let's draw our line. It's the same line. Yep. Two equations could look different, but actually end up being the same. So here then, it's technically true if both lines are laying on top of each other, aren't they intersecting or at least touching at every single point? Every point is an answer then. So for this, when they're both the same line, we just say that there's an infinite number. Infinite number of solutions. That's because every single point on the line counts as an answer. Does that mean? Yeah, I mean, basically all it is. This is an example for this. Might be given y equals, say, 2x plus 1. But then the other line, you might be given something like negative 2x plus y equals 1. So it kind of make it seem like they're not the same, you know, it's the same. But then when you go and graph them, you're going to see they're the same, exactly the same line. But obviously, we got to do something here to make it seem like they're not the same. All right, so the parallel is not a big deal. You can answer that. If they're the same line, you can answer that. What is the next thing that we're looking for here? Be the biggest one as far as you're concerned. If the points don't end up on a good spot, you can't use this method. Come out to be not whole numbers, not stuff. That's why we have other methods to solve them. So for 5.2, you do not need your graphing anymore. We only need it for 5.1. I'm not going to put the page back on. Here's a method called substitution. Substitution. So I'm putting the first system of equations up to try to make harder, to be honest. Look at the way I have the two equations. First equation. Do you guys remember what the name of this style of equation is? The first style of equation. Do you remember what they call that? It rhymes with Andrew form.
That's the one I asked you about. That's how to stem like.
I don't know. You can answer the way you want, unless it says it has to be slope intercept. You can do whatever you want. So here's our first one is given in that form. Second one is in slope intercept form. Right now, you can try to graph it if you want. So the first one, if you were going to graph it, you would have to go and solve it for y. But now instead, we're going to do this. Notice that in the second equation, that y is already solved for. So here's what I'm going to do. I'm going to take this y, this whole thing, and I'm going to replace that y with it. I'm going to literally substitute that into y. Well, look, I'll rewrite the first equation. The first equation is 2x minus 9y equals 7. Isn't that what y used to be? But what's so great about this, did you notice now, there's only one variable in this? Now I can solve it using my methods that we've done all semester. It's just an equation now. Something to make myself some space. Tell me then, how would you solve an equation like that? What would you do? What distribute the 9, right? Did you say distribute the 9? You know, I thought you said it shouldn't be that hard. No, you said distribute. So if I distribute the 9 for, remember, you're gonna multiply to both parts here. I'll get 36x plus 27, and that would be 7. What's the next step in solving an equation like this? Combine your like terms, so I'll get negative 34x plus 27 equals 7. Almost home. What'd you do now? Start. No, you're not. You're not. If I can get the other side.
Subtract both sides. 27.
Subtract 27 from both sides. When you're trying to peel away the left side, you get x by itself. So we're subtracting 27. I always think of it this way. You know, when you're trying to fix something you've never seen before, you open it up and you see if you can fix it. If it doesn't fix, you keep opening it, more and more. Kind of like this, I'm trying to dismantle the sides that all that's left is x.
See, I'm used to like trying to move to the other side.
The way a lot of students get, but you're technically, when you say move, you are subtracting. That is literally what you're
But
doing.
if it goes away, subtract it actually goes away.
Yeah. But I did the same thing too. I used to think of it as moving things around, and I don't know how much trouble you'll get in with that, but it's not, you obviously don't think that subtracting the same thing from both sides seems the same as moving stuff around, when they actually are. So that's when it's an issue. All right, I'm almost done. What next? Divide by negative 34, so you want to get x by itself. Now, admittedly, these are not as fun as the graphing ones. Can we simplify that?
17.
10 over 17, positive, right? All right, unfortunately, that's only half the answer. Do you remember these ones that have the answer where you got to tell me the x and the y? So far, I only know the x portion. So my answer looks like this so far. I have the x portion of it. 10, 17. Now I'm looking for the y again. How do I get that? Plug in the fact. You're in there. Substitution should tell you.
Check.
See that line? Remember that y equals 4x minus 3. Now you take 10/17 and put it into the x spot, and I'll get the number for y.
So you plug in.
Right, so I'm going to get 4 times 10 over 17 minus 3. And don't forget to make it 4 over 1 if that makes your life easier for you. What do we get here? 40 over 17 minus 3. Well, that's not quite an answer yet. What do I need to do to give me a good answer? It technically is the right answer, but I guarantee your homework's not going to accept that version of it.
Going up to 3/1 then,
So we got 40 over 17 minus 3/1, and then you're gonna do what?
go, make it, both the denominator the same.
All right, so I have 40 over 17 minus something over 17. Tell me what that new numerator is for 3. 3 times 17 is
51.
51. And we are practically done now. Finally, I get negative 11 over 17. So that's the piece that I needed for my answer. There we go.
I don't like this.
Well, you can see the answer would never be graphical.
Yeah, like that's fine.
That's a horrible answer. What happens is, unfortunately, when they teach you the number line, they show you the points. Like, yeah, it's like 0, -1, -2, -3, 1, 2, 3. But then just a little while later, they tell you, oh, between all those numbers, there's numbers. Right? In whole numbers, you got the fractions, you got horrible looking, real numbers that they have to choose, decimals, etc. So yeah, this graphing, but a graphing is limited in finding the answer. This will always get you an answer. No matter what, this will always work. Just the other question?
Like if you were to plug that,
It's not going to be pleasant.
none of them were.
We'll do it. Let's check it. Because yes, I'd like to check it. I'm so glad you'd like to check it. So we're going to do that. 10 over 17 to negative 11 over 17. So we're going to check it out here. No.
That's the only way.
As far as I know, and usually I would tell you there's more than one way to do it, but I don't know of any. What were my 2 equations? What was the first one? Oh. 2x minus 9y is equal to 7. Now notice they have the same denominator. That usually does happen. So it's not as terrible as you think. Plug it in. All right, now I'm going to plug those numbers in. So x I'm going to replace with 10 over 17. And y I'm going to replace with negative 11 over 17. Now you only need to go so far until you see that it actually works. Do you understand why I have a 2 over 1 and a 9 over 1? Or because that makes it easier to multiply. All right, so I'm going to get 20 over 17 plus 99 over 17. What's 20 plus 99? 190. Anyone do the honor? You can't believe it, can you? You can't believe it. It actually worked. I bet they had the same denominator, so they're going to play nice together. The other one was y plus 4x minus 3. Yeah, both of them got to work. So we have this is checked. Now I'm going to then replace my y with negative 11 over 17. My x I'm going to replace with 10 over 17. And then let's see if you can hang with me on this. You guys able to hang with me on that one? All I do is change that number to 3. Became 51 over 17. I needed a common denominator of 17. 3 times 17 is 51. So I did all that, so they have the same denominator. All I care about is if both sides equal out. And so I have negative 11 over 17 equals 4 times 10, that'll be 40. So over 17 minus 51 over 17. Do I need to go one more step? Or do you see it's going to be negative 11 over 17? So both sides check. So it's not as bad as you think though, because the fractions will work, will play nice together. They usually end up 90% of the time, these answers have the identical like denominator. Occasionally they don't, but they're still related. Like this one may be a 17, but this one will be a 34.
Got it. Yeah.
You'll have a relation like that in some way, shape, or form. All right, I gave you a bad one right off the bat. Now I'll give you more pleasant ones. The book gives you easier problems than I make up. Let's see here. We are going to pop to, I think, 5-2. Let's go to the end of this. Present it. Okay, so what you're going to want to do with each of these is to solve them just like I did. Remember, you want to get an X a value and a Y value. You need both for it to count as a solution. This one should be a little bit easier than what I just did. So please give it a try. Betting odds are these things don't last 5 years. Anybody? What'd you say? No solution. I didn't, because I didn't read the question before I signed it. We're gonna have these anyway, so it doesn't matter. Now, I think what's a good responsible thing to do is to look and see what's easier to substitute into what. The way I see it, since X is solved for, it's easier to plug X in to the first equation. Do you agree? This X is already solved for down here, so this whole expression right here can go right into that spot. So I can rewrite, I usually draw a lot of arrows here. My first equation that can become 2, I will replace the x, 6 minus 15y, it's my x. This is important. Since there's only one variable in this equation, then we can solve these equations and get a number. I'm going to distribute the 2 through. All right, you notice how the 30 y's cancel? And I'm left with just 12 is equal to 9. This cancels. You left with just an equation like that, that's a false equation, isn't it? You know this is no solution then. Now, you remember when we were solving the equations, no solution, this is how that came out. Do you remember the ones that had an infinite number of solutions? What would happen to that last step? Yeah, if there's another situation here, no solution, they're parallel lines, we already saw that. But an infinite number of solutions where they're the same line is if you end up and get an equation like 12 equals 12 or 9 equals 9, which is a true equation, but there's no variables, that means it's true no matter what letter what you plug in for the number, the letters. So this will tell us if we're going to have no solution or an infinite number of solutions just by looking at this. So I was wrong. We're taking care of the worst possible ones first. All right, now I'll open the book because it will allow me to find ones that I know are going to have solutions. So I didn't intend to do that one as one of my first ones. But now I want to do number 26. Yeah, maybe not. Let's do number 20 first. This time, hopefully you see the thing that's substitutable is what letter, X or Y. Y is the better substitutable one, isn't it? this is what your first set of equation, this first equation should look like. This does yours. See where I plugged in? And now you just substitute. With that negative in front, students miss this a lot of times because I don't know what they need to do to remind themselves. I've had students in the class in the past put like a -1 in front of there. Does that help? I don't care what you do. What I want you to do is give me the second line. That's all that matters to me is you can get that. Whether you do this little trick or not, it's not even a trick. It's just something the students do that they feel helps them. But, oh no, that's separated. That's not, the two's not times that. Well, maybe you need the -1. That might help you out. All right, so then when I 2x minus 3/2 x, that's going to be 1/2 x. What next? I wouldn't multiply everything by 2, to be honest. I mean, what? If I subtract 5 from each side, I get 1/2 x equals 0. X is going to be equal. Sorry, 0. All you gotta do is multiply that equation by 2, right? What's 0 times 2? So I get the x value. Now, do you remember what the easiest way to go about getting the y value was? Well, I get the answer for x. You're actually going to be finding yourself a y-intercept. So we're going to take our x equals 0 and we're going to plug it in to y equals 3/2 x minus 5. So y is just equal to -5. So it looks like our answer then is 0, -5. Now, these are time consuming. The way I'm looking at our time, always doing ETA. So I'm trying to keep that in mind when I come up with my next problem. Should we do a nasty one or should I give you a more regular one? What's that? I won't put I never put nasty ones on the test, but I could do a nasty one or leave it for homework. And then we talk about it in the next class. We see, I said one nasty, one not one. How about you, nasty or not? All right, she doesn't want nasty, so. Yeah, I think you're gonna have to do some research on your own. Well, you'll get one tonight, trust me. When you, all right. I've already plugged it in. All right, so I'll try to find one that is not so unpleasant. Number 26 then. So we'll stay out of the nastiness. That's true. We didn't, yeah, because well, don't forget, do you guys remember that I have online videos, not just the WebEx videos, but they align up for other sections. So this is part of that. If you go and do it, you can go find it easily. And it's the same as a lecture. Except the only thing with those things is I don't pause to answer questions because, well, there's nobody there. Right here, this is more reasonably like now you're not given an X or a Y, you're going to have to work a little bit. Is it? You know, it didn't give you a real good starting point, did it? Start with one of them solved. Technically speaking, the method that we're gonna do on Wednesday is what I would use for a problem like this. But these are in the homework, so I thought I would throw it at you. Because it's, I wouldn't think of using substitution right off the bat simply because neither letter is solved for. I don't solve for, I don't have to solve for it. To me, nothing is easier to substitute in than anything else. So what I'm gonna do, well, let me put the answer and see if anybody got it. -1. Nobody's celebrating, so I'm guessing that. No. Well, what we gotta do first, let me use one of the equations and solve it for a letter. So I'm gonna take the first equation. And you know, we're kind of used to this anyways, aren't we? Aren't we used to solving them for y anyways? As well. So then I'll just divide by 6. So I'll get y equals -4 6th x minus 13/6. Do you think I should simplify that 4/6? Do you think that'd be useful? That's always, it never hurts. It usually does make things easier to work with. So I will simplify a little bit. Now then, what I'm gonna do is take this guy, and where am I gonna put it at? In the other equation, where the y is. It's gonna go right into that spot. So our equation there becomes 7x minus 4. I'll replace the y with -2/3 x minus 13 halves, and that equation was equal to 1. Not pleasant, but I only have x on them. I only have one variable. As usual, you distribute now. Distribute, distribute. When I do to this, I'm going to get positive 8/3 x. And when I do this piece here to here, I'm going to get plus 6. Simplifying a little in my head. I need to look at this a little bit. I need to combine the x's together. How can I do that? Seven over 1. I'm going to rewrite this as 21/3. So that 7x is 21/3x. 8/3 x. It's 26. Well, you can see why I would go through the trouble of getting 21/3. Now I combine my x's together. 9/3x plus 26. I think there's a mistake. Or here, let me check. See what I did? Might as well make my old small point. I just decided to change the 6 to a 2. You notice or no? Obviously not. This will become actually 26/3. 26/3. All right. How would you solve an equation like that? What would you do next? I personally would multiply everything by 3.
I want to up.
Because that, if you multiply everything by 3, it's a really simple equation to solve. So if I multiply the left and the right by 3, all those fractions will disappear, and I'll get 29x plus 26 equals -1. Subtract 26 and we get 29x equals -29. And then if you divide by 29, get your x equals -1. Very almost. Then the y is -2/3.
I think you put the 29 on there. 26.
It's because, like I said, the old folks home day cry. Orientation is at 4. Should have been pretty obviously.
Now, x still does equal -1. Now, our y was equal to -2/3 x minus 13. So my answer for x was -1. And then 2/3, if you think of 2/3 as 4/6, we end up with -9/6, which is -3/2. So there I have my x and my y. You can, we run out of time. So you can look at this later if you need to help. It's a lot of steps. Remember this too. When you come back on Wednesday, you can ask questions. If you ask them questions, my assumption is you know how to do it all. Okay?
All right, let's get out of here. Stop the recording.